Good morning. How should I say this? Gentlemen and Shaylee, welcome to Algebra 2 class and room 15 where we're in. How did you like that, gentlemen and Shaylee? Did you like that?
Yeah, I like that.
That was good. I liked it. So what we got to do is we have so really in this class left, this is what we have for a girl. We have Shaylee and Carly, right? Well, Caitlin isn't enrolled in this course anymore.
What?
I don't know what happened to Caitlin. Anybody know what happened to Caitlin?
She said she's gonna be back Monday.
Yeah, she
Oh, really?
come back.
Okay, all right. Well, then she'll be back, but she's not on the roll currently, so that's a strange thing.
What, she's going to school down in Disneyland?
I don't know what it is, but anyway.
She works at Disneyland now.
But we have a little bit of a challenge in this class, and I'll just say that is because we've lost some people, and we lost Tyler, right? Tyler, you gotta admit, he's kind of a big loss, isn't he? So it means that it's kind of up to the rest of us. And he's helping out first period now. First period's bigger, and that's fine. But this class, I think this class has been a good class. Most of the time when I post the videos, I post from this class. Did you know that? Well, that's true. That's true. Another thing that happens is there's a little bit of accumulated wisdom coming from first period to second, because what happens is somebody might make an insightful comment during first period that I'll be able to bring up here and make that part of our discussion here today. So, which is going to be the case today, because I had Colby the first period who made it very good, and Kaylee too. So anyway, we're going to be going into chapter 7, which has to do with polynomials, adding, subtracting, and 7.2 is multiplying, 7.3 is factoring, and 7.4 is polynomial division. And so we've been working on polynomial division recently. And so what we're doing with this is we're kind of cycling back to where we started the school year. But so we're taking a second stab at it. And so it's part of the way that we're trying to work with our education. We're trying to spiral through and cycle through and come back again. And then as we do that, we gradually, things better adhere to our minds and our understanding. And so the first thing we're going to talk about is identifying, analyzing monomials and polynomials. And this comes to, there's a definition of something called a term, and we'll talk about what that is. And we have it talks here at the beginning of the book about what a polynomial function of degree n has the standard form, and we'll go ahead and drill down to what that is better here. But we're going to start out right here with, it says identify the monomials. We have x cubed, and then we have, so that's separated by a comma, then y plus 3y squared minus 5y cubed plus 10, and then there's a comma, then a squared b c to the 12th, then comma 76. So it's asking us to identify here, of these four things here, they're separated by commas, which ones of these are monomials and which ones are not monomials. So do you have any idea for that? I don't know how well you can see from there. A lot of you don't have 2015 vision like I do. Corrected the context. Which one of these are monomials? Okay, basically your monomials are things that are not separated by plus or minus signs. Right, where there's just one term. And so this thing right here, this y plus 3y squared, etc., that is separated by plus and minus signs.
A, B, C.
Yeah, so what happens is, yeah, so I'm going to put the not monomial first because it's going to be definitely this one. So we have y plus 3y squared minus 5y cubed plus 10. So that definitely is not a monomial, but the rest of these are. We have x cubed as a monomial. We have this a squared b c to the 12th power that is a monomial. Finally, this 76, this number by itself. And then it says, and it's at B, it says identify the degree of each monomial. And so we're given, what is our degree of this x cubed? What is the degree of that monomial, x cubed? Our degree is?
2.
What power is this right here? It's hard to see.
3.
3. So degree is 3.
All
Right? Yeah, so it's a little bit hard to see. And another thing that doesn't help is this distance. And so the next thing here, a squared b c to the 12th, what's our degree of that monomial?
14.
What did you say?
14.
14? Yeah, Luke says 14. Actually it's 15. Now I see why Luke said 14, right? That's clear. And the reason it's 15 is because we have a squared b to the first power, and then c to the 12th. And so all the powers considered together with that first power b, that's 15. And then what's our degree of this 76? What's our degree of that polynomial?
1.
Okay, it looks like it's 1, but it's actually 0. And do you remember when we were doing the polynomial division recently? Synthetic division and all that? Where we had, we put in standard form, the last thing we put was the number. So what those are is they are ranked, and the number at the very end is 0 because this is actually 76 x to the 0 power. So that's what it is. It sounds kind of strange, but that's what it is. We call a number by itself a 0, a 0 degree monomial. Okay, next it says identify the terms of polynomial y plus 3y squared minus 5y cubed plus 10. And your terms are everything that is separated by a plus or minus sign. So these are all separated, that I'm underlining these 4 things. Each one of these is a term. They're separated by plus or minus signs. And the next thing is identify the coefficient of each term. So what's our coefficient of y? A coefficient is a number. What is the coefficient of y? It is 1, because it's really how many of these things are there? Well, it's 1y. And then for 3y squared, what's our coefficient there? Okay, it's actually going to be 3, because it's how many of theirs are. Then this minus 5y cubed, what's our coefficient there?
-5.
That'll be -5. And finally, a coefficient of 10 is 10. And again, it's going to be like 10x to the 0 power. And next it says identify the degree of each term. So what is our degree of the term y? Degree
0.
degree 1, because it's like y to the first power. Then this next one, our degree is going to be,
Is it 3? I can't.
yeah, it's going to be 2.
I can't remember.
That's why it's kind of hard to see. And then I think it's really, then our degree of this one is 3. And finally, what's our degree of this 10?
0.
0, okay? So yeah, you're catching on here. And then lastly, it says write the polynomial in standard form. And so what does standard form mean? Powers written in order from what?
Least degree.
Greatest to least. Greatest to least. So we see this cubed here. So we have minus 5y cubed. That's our first one. And the next one we have is plus 3y squared. And then we have, next one we have is plus y. And finally we have plus 10. And then the last thing down here, it says what is the leading coefficient of the polynomial? What's our leading coefficient? Any ideas? It's a number. What is that leading coefficient of this polynomial here?
-5.
Okay, it is going to be -5. And what happens is this thing here is called the leading term of this whole polynomial with 4 terms. Why do you think it's called the leading term? Any ideas from that?
First.
It's the first one we put in standard form, so that's a reason for it. But it even goes deeper than that, because what happens is the leading term determines the overall character of what the polynomial does. You know, in this class we talked a lot about odd, even, right? And so what this does is this leading term really affects the basic characteristics of the function, in behavior especially, where the thing starts, where it ends, the steepness of it. Why? And so what happens is all these other things here, in this case we have all these other things, the 3y squared and the y and the 10, since they are not leading terms, as we go, as x approaches infinity, as x approaches negative infinity, or in this case they're using y instead of x, but if we had usually see these written in terms of x, but as x approaches infinity, what happens is these other terms, their influence will pale in insignificance in comparison to what the leading term does. So this governs overall the characteristics, definitely the end behavior characteristics, whereas as we go toward positive infinity, negative infinity, these other ones just are insignificant at that point. So that's one reason we call it the leading term. And then what we're going to be doing is we're going to be adding polynomials is one thing we're going to do. And what we do in the book here, they give us a couple of examples of how to do this. And so basically the way they recommend in the book doing is when you have 2 polynomial expressions like this, that you kind of stack these underneath each other. And what that does is it enables you to kind of keep track of what's going on. And so we have 3 terms over here on the right, and we have 5 on the left. So what we're going to do is stack this first expression underneath the second one. And so we have plus 11x cubed. So we go here and look for the x cubed column, which is right here. So I'm going to put 11x cubed. Let me get the right one. 11x cubed right underneath this one here. And then we have minus 8x squared. So I'm going to put minus 8x squared right underneath this x squared here. And then we have plus 12. We put plus 12 here. And so what we're going to do is add all these together. And so if we just kind of go from left to right, we have 17x to the 4th power. And then we have 8x squared minus 8x squared, which is 0. So that's going to be 0. And so I'll just put 0 here. And then we have negative 9x to the 7th power minus 9x to the 7th power. And then we have 4 plus 12, which is 16. And so what we're doing here is I'm going to ask the question after we do this. So negative 2 plus 11 is plus 9, right? So this process of adding these things up is what do we call that process? And you've heard it before. I'll say it to you again. It's called combining like terms. You ever heard that before? Yeah. So that's part of it. And the last thing we have to do is to add these up is to rewrite this in standard form. And to do that, which one is our starting one we use? Yeah, so we're going to use the negative 9 x to the 7th power. And then we go ahead and look for the next highest power. And so we see next this plus 17 x to the 4th power. And then we have this plus 9x cubed. And finally we have the plus 16. Okay? And so that's really what there is for it. That's not that hard, is it? Yeah, pretty simple. What I want to do is we're going to go to subtract. And subtraction process is pretty similar. The way the book recommends it, and I really like the way they do it. What happened here? I'm missing the your turn one. Okay. I'm going to try something here. I'm going to say no. No. I'm going to try to call it up again because somehow I erased a page, I think. That's homework. This one right here. There we go. I'm going to try to pull it up again because I erased a page somehow. I must have done it with all the confusion that was going on today. And part of the problem is since I didn't have that top row working, I had to come up here and press things up here, and I couldn't just, so I probably made a mistake, and I accidentally erased a page. We're going to soon find out. Adding, your turn, subtracting, your turn. Yeah, I erased a page. Here I found the page I had erased, right? Good. Okay. Well, it happens. It happens. I had to redo a whole SAT test that I erased a lot of stuff from that too. But anyway, the technique they suggest here is, and I agree with it 100%, is what you do is, basically what you do is you change this into an addition thing here. Because we have this, we're going to subtract out the second one here. And what you do is you distribute the negative sign to everything inside the parentheses here. So we end up here on the right side with plus 9x to the 4th power, and then minus 6x squared, and finally the plus 31, because minus minus, and then we can stack underneath. So what we've done here, the technique is basically turning the subtraction problems into addition problems. And so having done that, we're just going to go here and stack underneath where we can. And so we have this 9x to the 4th power, so we're going to add 9x to the 4th power right here. And then we have minus 6x squared. I don't see it anywhere, so I'm going to put this minus 6x squared off to the side, like this. And the plus 31, where does that go? Right over here, under the x to the 0 location. And so we add these up, and these two here, I notice, will cancel to be 0. And so we have negative 6x squared plus 23x to the 7th power. And finally we have 1 plus 31, which is 32. And then we just put these in standard form order, which is highest power first. So we get 23x to the 7th power. And then our next highest power is this squared, so we have minus 6x squared. And finally we have plus 32. And so really, that's all there is to it. Does that look very difficult? No, it shouldn't be bad at all. So let's go ahead and I'm going to hand out a sheet here to work on. We'll just do these today. Just leave it here. Okay, what we have here is this one right here, evaluate homework and practice. So it says write the polynomial. We have negative 23x to the 7th power plus x to the 9th power minus 6x cubed plus 10 plus 2x squared in standard form, and then identify the degree and the leading coefficient. So I'm going to call on somebody from the class to give us the answers. I happen to call on Colby for this first period. He did a good job. Had some good discussion. I really don't have very many to choose from here. We're getting toward the last of the week, so we have. Okay, for this one we have Logan. So Logan, you have a rewrite of this in standard form.
Working on it.
Okay.
I can't really see the powers on here. Like,
Yeah, what they are here. You have negative 23 x to the 7th. This is x to the 9th. Negative minus 6x to the 3rd. And finally, that one is 2x squared. Now, does that help you?
yeah.
Yeah. So what do we have here?
I'm not really too confident in it, but I got x to the 9
So we start out with x to the 9th, okay?
minus 23x to the 7th.
23x to the 7th, you say? X to the 9th minus 23x to the 7th power.
Minus 6x cubed
6x cubed
plus 2x squared
plus 2x squared
plus 10.
plus 10 Is that right? Looks good? Okay, that looks good. Okay, good job so far, okay? What is gonna be our, this is correct, so what is our degree of this gonna be?
9.
Degree is gonna be 9. What is our leading coefficient? Leading coefficient. Is 1, because there's 1 x to the 9th power, okay? So really, that's that one. Do you have any questions on that one? Not too difficult. Now I had a good question from Colby in first period, who asked, well, do we have to put placeholders for where there are not powers? Well, the answer to his question was no, but I'm glad he considered it, because we have to consider it if we're doing something like polynomial division, don't we? So that was very good consideration. So thank you, Logan. What we're going to do is we're not going to finish this today. We'll probably come back here next Tuesday on number 2. I'm going to call somebody in advance to do this, like we did in the first period. So that person who's going to help us out first period with this is going to be Preston. So Preston, you're going to be up for this on Tuesday, all right? So let me give you a sticker here, Logan. Thank you.